When talking about imaginary and complex numbers, a continuation of what we talked about in class, today we're going to discuss how to simplify powers of I. Remember, I is by definition the square root of -1. It is the imaginary component to a complex number. So if talking about real numbers for a minute, if x is equal to the square root of 2, then x squared is equal to 2, because when you square a radical number with an index of 2, remember that is the number right there. If you square a number that is under a radical, really what happens is that the radical just disappears. And this will hold true for any type of value in the radicand, whether it's a number or whether it's a variable, as long as this remains positive. Then really again what happens is that the radical disappears. So if I to the second power is being evaluated, that means the square root of -1 is being evaluated, and again we're talking about the radical disappearing, and what we're left with is -1. This is what we discussed in class and why I squared is equal to -1. So let's look at some other exponents and see how I, the imaginary number, behaves. First of all, anything to the 0 power is equal to 1. This is a definition of 0 as an exponent. We discussed this as well when we did our exponents unit. Anything to the first power is itself. This is another basic property of exponents. We talked about I squared, so let's talk about I to the third power right now. Remember how exponents behave when multiplication is involved. The exponents get added together. So this is how, when we simplify radicals, when we talk about simplifying, let's say, x to the 5th power, the square root of that, we can factor this into x to the 4th and x to the 1st, because again 4 plus 1 on the exponential level is equal to 5, and that's factoring because multiplication is happening on the base level. So that means I to the 3rd can be factored into I squared times I to the 1st. Since we already know that I squared is equal to -1, that means it can be replaced. That means -1 times I, which again, I to the 1st power is just equal to I. That means -1 times I is equal to -I. So that means I to the 3rd is ultimately equal to -I. Let's look at I to the 4th power. I to the 4th power can be factored a couple of different ways. Let's use I squared and I squared, because 2 plus 2 is equal to 4. That means both of these I squareds can be replaced with -1, because that's what they're equal to. And -1 times -1 is a positive 1, which means I to the 4th is equal to a positive 1. Let's look at I to the 5th. I to the 5th you can break up in any manner you want to. Again, as long as these exponents add up to 5, we can use 2 plus 2 plus 1 to get 5, which means we'll be getting -1 times -1 times I, and that's equal to just positive I, because -1 times -1 is positive 1. But let's see if we can break this up another way, using I to the 4th power. Because 4 plus 1 is equal to 5, this still works. I to the 4th being equal to 1 means you can replace it with a 1. 1 times I is equal to I. This is preferable because positive 1 is preferable to multiply than -1. We don't have to take care of the signs. Multiplying by 1 is great. So if we want to look at I to the 6th power, that means we can utilize I to the 4th and then I to the 2nd. And then 1 times -1 is -1. Looking at one more, I to the 7th power. We can utilize 4 plus 3 to get back 7, so we can factor it in that manner. That means 1 times negative I is negative I. Right, again, utilizing I to the 4th power is nice because 1 has one of those properties where it's very easy to multiply, very easy to raise to exponents and so forth. So let's recap. We got I to the 0 equaling 1, I to the 1st equaling I squared equaling negative 1, I to the 3rd equaling negative 1. And then if we jump to the higher powers, I to the 4th, 5th, 6th, and 7th, respectively, those values are equal to 1i, negative 1, and negative I. So hopefully, what you will see here is a pattern. Take a look at these values here, and then take a look at these 4 values here. Now, without doing any factoring, we can see that these 4 values are repeating every time we reach I being a multiple of 4. So that means I to the 8th power is equal to 1. Then I to the 9th is equal to I. Then negative 1, and then negative I, to get I to the 9th, 10th, and 11th power. So we're going to utilize this pattern in order to simplify any power of I that we encounter. So the first thing we're going to do is divide the exponent by 4. And we're going to use long division, and you'll see why. We recapped long division when we did polynomial division, so we're going to utilize long division here, and it's going to be just with numbers. So not with polynomials, but we're going to utilize long division, and you'll see why in a minute. Let's simplify I to the 29th power down here. So we're going to divide 4 into 29. 4 goes into 29 7 times. 7 times 4 is 28, and we're going to subtract to get 1. And this is an important piece, the remainder. Dividing using our calculator doesn't give us remainders. There's a way to get the remainders, but I would rather see you do the long division so you can generate those remainders organically. So we get 7 with a remainder of 1. That means this I to the 29th power can be factored utilizing I to the 4th times I to the 4th times I to the 4th times I to the 4th 7 times. That's what this 7 represents. After the 7 I to the 4ths have been written out, there is I to the 1st left over. That is where the remainder of 1 comes in. Now, I don't expect you to write this out this many times, because this number could just as easily be 25 or 30. I don't expect you to write out I to the 4th times I to the 4th or whatever, 35, even 15, even 7 times. Instead, we can write this using exponents. I to the 4th is the base, and it's getting raised to the 7th power, multiplied by I to the 1st power. Now again, I to the 4th can be replaced with a 1, which means 1 to the 7th power is equal to 1. That's 1 times 1 times 1. It's equal to 1 times I, which is just I, and this is our final answer. Let's try another. We got 3 more examples to go through. Let's simplify I to the 115th power. This is a high number, but you'll see that it really doesn't add much more difficulty to this problem. Let's do this long division. Let's do this long division organically. I'll erase it. I'll show it to you live here, okay? So we're doing 115 divided by 4, and again, we're always dividing by 4 because that is the number of patterns that repeat. That's the number in the pattern. So 4 goes into 11 twice. 4 times 2 is 8. 11 minus 8 is equal to 3. We bring down the 5. And then 4 goes into 35 8 times. 8 times 4 is 32. Subtract it to get 3, and that is our answer, which is 28 with the remainder of 3. Now I will write out the solution. Let me delete it and then rewrite it for you. So that means I to the 115th power, that's what we started with, is equivalent to I to the 4th power raised to the 28. Again, that is coming from our quotient. Times our leftover, our remainder, I to the 3rd power. I don't like the way I wrote that 3. This should be down here. You know what? It's a remainder, not an exponent, so there. But again, so this remainder of 3 goes in that slot right there because 4 times 28 plus 3 is going to get us 115. But remember, we can substitute I to the 4th with a 1. We can substitute I to the 3rd with a negative I. And this means 1 times negative I is equal to negative I. And this is our simplification of I to the 115th power. Let's look at number 3. Again, these solutions are done already, so I'll just circle them and highlight them as I talk. But we're going to take 76, we're going to simplify I to the 76th power, and we're going to do long division. That's 76 divided by 4. 4 goes into 7 once. So 1 times 4 is 4. Subtract 7 minus 4 to get 3. Bring down the 6. 4 goes into 36 9 times. 9 times 4 is 36. And 36 minus 36 is 0. So here we are getting I to the 19th power. No, sorry. We got an answer of 19 with the remainder of 0. So I to the 76th power we can rewrite using I to the 4th with parentheses raised to the 19th. Times our leftover, which actually is not a leftover, but still has to be written down so that we can generate our final answer, which is equal to 1 times 1, which is 1. All right, so remember, I to the 4th is equal to 1, so that's 1 to the 19th power, which is equal to 1. And anything raised to the 0 power is equal to 1, including the imaginary number. Let's do one more. Let's simplify I to the 134th power. Again, a large number, but we saw getting into the 115th power, it's not that big a deal. It just means our our division might be slightly longer, but again, we know the procedure. 4 goes into 13 3 times. 3 times 4 is 12. 13 minus 12 is 1. Bring down the 4. Start that process over and over again. Now 4 goes into 14 3 times. 3 times 4 gets us 12, and we'll subtract to get our remainder of 2, so that's 33 with a remainder of 2. And that means I to the 134th power is equivalent to I to the 4th raised to the 33rd times I to the 2nd power. 1 to the 33rd power is equal to 1. That's how we get this 1 over here. I to the 2nd power is equal to negative 1, so that's how we get that, negative 1 there. And then 1 times negative 1 is equal to negative 1. So I hope this clears up on how to simplify these powers of I. This method can be utilized for any numbered exponent of I in existence. All right. Thank you for watching.